Welcome to the numbers game. I'm Coach T, and in this tutorial, we'll be finding the arc length of a curve. Let's get started. In our example, we're given a curve, we're given the bounds, and we're asked to calculate the arc length. So let's first go over the arc length formula. So arc length is represented by S of t, and the arc length formula states S of t equals the integral from 0 to t of the magnitude of the derivative of the curve with respect to u. So our arc length formula is going to be L, our arc length, equals the integral from 0 to 2 pi of the magnitude of the derivative of our curve with respect to t. When we take a look at this formula, we see that it makes the most sense to first start with finding the derivative of our curve. So let's start with finding the derivative of our curve. Now we see that the derivative of 3 times cosine of t equals negative 3 sine of t. The derivative of 3 sine of t equals 3 cosine of t. And the derivative of 4t equals 4. So we've got the derivative of our curve, and now we need to find the magnitude. Our magnitude is represented by the square root of negative 3 sine of t squared plus 3 cosine of t squared plus 4 squared. Simplifying, we get the square root of 9 sine squared of t plus 9 cosine squared of t plus 16. Now we can factor out 9 to leave us with sine squared of t plus cosine squared of t, and our trig identities tells us that's 1. So that'll leave us with 9, or the square root of 9, times 1 plus 16. 9 plus 16 is 25, and the square root of 25 equals 5. Now all we're left to do is evaluate our integral. That is L, our arc length, equals the integral from 0 to 2 pi of 5 with respect to t. This equals 5t from 0 to 2 pi, and we get a final answer of 10 pi. And there you have it. That's how you find the arc length of a curve. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.